All right. Hey, everybody. It's Miss Aninga. And I was going through and looking at your bonding reviews, and I was noticing that specifically with like the ionic bonding stuff, there is a huge disconnect or misunderstanding or just plain not knowing, people don't know how to find charges from their periodic table or the valence electron count. So I wanted to go over that very basic stuff because that's where I feel like we're having the most problem is that fundamental. If you don't know how to find the valence electrons or the charge of your elements that you're bonding together, you're going to have a real hard time with bonding. So I wanted to do this quick help video for people who were lost in how to do that. So, we're going to start with the periodic table for one thing. So the periodic table is your meat and potatoes help for bonding because obviously it has your elements on it that, you can see where they are. But the shape and where these elements are can also help you with valence electrons and with charge. Okay, so we have our columns numbered from 1 to 18. Now, the columns, if you remember, that are set up on the table are really important because they have fixed numbers of valence electrons that they each have. The stuff that's set down, like all the transition metals, we're going to ignore when it comes to valence electrons and charge because they're all mixed up and they have crazy numbers depending on the type of what do I want to call it? Isotopes you have. So those we're going to ignore. Same with the lanthanoids and actinoids. We're going to ignore those for bonding's sake for right now. So when we look at it, we notice that we have columns 1, 2, 13, 14, 15, 16, 17, 18. And they all have a number from 1 to 8. All in order. These ones, you just had to drop the 1 in front. This is your valence electron count. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? This helps a lot when you're looking at covalent bonding because you can make your drawings and your Lewis dot structures. Okay? However, this also knowing your valence electrons also helps with finding your charge. So with your columns 1 and 2, it's really easy because charge comes from the octet rule. And if you did your definitions, you know that the octet rule talks about wanting to get to 8 electrons. So this rule talks about elements where they want to get 8 valence electrons or electrons in their outermost energy level or outermost shell to be stable. 8 is that lucky number that all elements want to have in their outer energy level, with the exception of hydrogen and helium. And the reason for that is hydrogen and helium are so small, they just want to have 2 in their outer shell, okay? Because they're up here. The very closest energy level, the maximum electrons you can have is 2, And so that's why it's just 1 and 2 on the upper side, up top. So, but everybody else wants to have 8 valence electrons in their outer level to be stable. So if we look at something like lithium in our very first column, we notice that lithium has 1 valence electron. It wants to have 8, or a full outer shell. And if you think about it, lithium has, it has 2 in its innermost shell, 2 electrons in its innermost shell, and then on the outer shell, it has its valence electron shell, it has 1. So if it wants to have a full outer shell, it either has to pick up 7 electrons, has to find them, or it can ditch this 1. And I would guess, just like any of you, if you had to, find 7 things or get rid of the 1 thing you had, you would probably just get rid of the 1 thing you had. And so that's exactly what lithium does. It ditches this 1 electron so it can have its full outer shell on the outside. Electrons have a negative charge. So when you get rid of something that's negative, your overall thing becomes positive. Because it's just like in math, if you take a number that's 0, I'm just looking for some post-it notes here, folks, sorry. Post-it notes. Here's an empty one. In math, if you take a number that's 0, so if you take 0 and you minus a 1 from it, like you get rid of 1 charge, like if you get rid of a negative number, so if you minus a negative 1, if you do that mathematically, 0 minus a negative 1 is positive 1. Okay, this is why lithium has a +1 charge. Okay, this goes for every element that has 1 valence electron. And notice this whole column has 1 valence electron. That means the charge of this column is +1. Okay? Similarly, down the line, if we look at column 2, we can see that column 2, like magnesium, has, it has 12 electrons, has this level filled on the inside. Then it has the next level, which has 8. And then on its outermost level, because it has supposed to have 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it has 2 left over in its outermost shell to make 12. Okay, same thing with lithium. It either has to pick up enough to get to 8 out here, which means it has to pick up 6, or ditch these extra 2 valence electrons. And it's most and magnesium is going to ditch those. So again, 0 minus a negative 2, 0 minus a negative 2 is positive 2. This is why all elements in group 2 or column 2 has a charge of plus 2. Okay, you can see a pattern here. Plus 1, plus 2, plus 3, plus 4. Now you're looking at this and you're going, but it says plus minus 4. This is where it's going to flip on you because that magic number is 8. Here we have the conundrum that carbon and everything else in column 14 has 4 valence electrons. 4 is halfway between 8 and 0. So it can go either way. It can gain 4 or lose 4, and it will be happy. Okay? So that's why it's a plus minus 4. And then we move on to column 15 or group 15. If we look at that, it has 5 valence electrons. 5 out of 8. Are you closer to 8 or to 0? So, if you write a number line, you're here at 5. Is it faster to get to 8 or to 0? Well, 5 is 1, 2, 3 from 8, and 1, 2, 3, 4, 5 from 0. So it's easier for, elements that are closer to 8 to try and pick up that many electrons in order to get to 8. So in the case of, our column with 5 valence electrons, it wants to gain electrons instead to get to 8 because it's closer to 8 than it is to 0. So that's like saying 0 plus negative 3, which of course is going to be negative 3. Okay? So thus our group 15, our group with 5 valence electrons, all of these have a negative 3 charge. As we get closer to 8, our charge needed to get to 8 goes down by 1. Oxygen has 6 valence electrons. It needs 1, 2 to get to 8. So it has a negative 2 charge because it'll gain 2 electrons to get to 8. Fluorine and everything in column 17, since they have 7 valence electrons, they only need 1 to get to 8. They want to gain 1 electron, so they have a negative 1 charge. Our noble gases here, they're already at 8 or a full outer shell, so it doesn't matter. They're all happy with 8, so they have a 0 charge. Okay? So I feel like that, I've gone over that, but it's been lost since we took a break, or some people were just confused on it to begin with. So just know that the columns that are set up, that are tall, are important, and it goes from 1 valence electron to 8 from left to right. It follows the numbers that they have here in their column number. For the ones that are over 10, just cover the 1 on that. Whereas for charge, it is starting out 1, 2, 3 from the left to the right, but it's also 0 here, -1, 2, 3. Okay? If you have a periodic table at home printed out, like, if you still have the one that I gave you at the beginning of the year, I highly, highly, highly suggest that you write these numbers on your periodic table above it, like above the numbers, like I have done here, because it helps you out a whole bunch. This is your resource for you to use in in like this bonding section. Okay? So I wanted to see and make sure that everybody knew this very fundamental information, because this is very important to know what your periodic table says to you and how you determine charge and valence electrons. Okay? Remember, for charge is only helpful for ionic bonding. Valence is for covalent bonding. Okay? Ionic, covalent. Okay? I really hope this helps, because this, I noticed that, like I said, that was something that was seriously missing. Like, it looked like everyone was confused on that certain section, and that's exactly why I put those columns, these ones, on these sections, because valence electrons help a lot as well as charge. Okay? All right. So if you knew about this, then, I'm sure you've already clocked out by now, but if you didn't know about this, I hope this helped. And let me know if you need any other help with bonding stuff. All right. Bye, everybody.